Hello everybody, my name is Pablo Glombowski. In this video I'm showing you how to perform early injection. So in previous videos I have showed you how to inject the library inside the process. What I was doing was to code a kind of generic injector where each 5 seconds more or less I try to list all the processes that are in the system, and for each new process that matches the criteria, the name, for example. In this case I injected the code. This is not nice, because the sooner you inject your library, the best. For example, take into account kind of antivirus that must scan libraries that are loaded. Okay, one of the first library that should be injected should be your library. By this way you can hook the LoadLibrary API and you can detect when each library is loaded, okay? Or an EDR software, for example, that must collect activity. Typically an EDR, for example, when a process is, or when an executable is created for the first time, it runs it typically under a certain security environment, okay, app container, and it let the program run, and it analyzes what the program does by hooking APIs and by analyzing the behavior of the calls to the APIs. So or encryption and decryption, where you must encrypt all the files that are written, and you must decrypt all the files that are open for reading. The sooner your library gets injected, the best. In this URL you will find all the sources that I'm showing. Let's take a very small example. Suppose that I have this library. This is a very basic DLL that when it runs, it simply in the attach event displays this message, this text in the message box, okay, that the malware library was successfully loaded. The name of this library is, as you can see, malware library. So what I want to do is to try to avoid loading libraries where malware is part of the path, okay? So this library should never be loaded. And so this is the library, and let me, for example, show you a little program that I did, that is load this library. It's a very small C program where it basically takes an argument that is the library to load, and it loads this library. In my case everything is 64 bits, but it can be 32 bits also. So let me show you. Now my hooking DLL is not running, okay? So this is the command line that I'm going to execute. So let's open CMD. Okay, so now again my hooking DLL is not running, so everything should run okay. I launch it and it says that the malware library was successfully loaded, of course, because my library is not yet loaded. This is a very small video, okay? I mean, here I will inject my DLL in Explorer. I will do it manually using Process Hacker, that is a very known software, okay? It's a free software, it's very interesting. So here you go to miscellaneous, inject DLL, you select the DLL you want to inject, and when I go to Process Explorer from sysinternals, it's another interesting utility. If you go, you can see that the hooking library is successfully loaded. So now let's do again the same test. cmd, okay, and I execute the same command. In this case, see that there is a message box that says preventing this library from getting loaded and the path of this library, okay, and the little program says that it could not load the library, malware library. See that cmd is here and the hooking library, cmd, and the hooking library got loaded, and that's why it behaves okay. So how does my little library or security library, it's very basic, okay, what does it do, okay, so how does it behave? So it basically hooks. I will not explain because I have already done this in another video, but I hook for APIs, for Windows APIs: LoadLibrary A, LoadLibrary W, LoadLibrary X W, and CreateProcess. These three APIs, of course, takes care of loading the library. So when the process calls LoadLibrary or LoadLibrary W or LoadLibrary XW, this function is executed, okay. Sorry. So basically speaking, what it does is to check if the library should be loaded. If not, okay, because the library contains the malware, it's very basic, but it basically checks if the string contains malware. In this case, it prevents it and it shows the message box that I have just shown, okay, saying that preventing this library from getting loaded, okay. This is not the interesting part of this video, but the more interesting part of this video is this, that performs the early injection, okay. Here what I basically do is, when the CreateProcess API is called, instead of letting it run as usual, I add this flag, okay, create suspended flag. See that I add it, okay. So I add it and then I just call the CreateProcess with this flag, okay. Once, why do I do this? Because I want the process to get created in suspended mode. When it is created, I load this same library, okay, this hooking library inside the process, okay. This has been shown in another video, okay, but it's basically the same principle, where I check if the process is 64-bit or not. If it is 32 bits in this case, I launch another process, because 32-bit DLLs should be loaded only by 32-bit processes, and the same for 64 bits. So well, here basically speaking, I allocate the memory space, okay, with the page read-write permissions. I write the path of the library. I create a remote thread, okay, that calls LoadLibrary, okay. And then I just free all the stuff, and once this library is loaded in this process, I resume the process, I resume the thread, okay. So that's how, this is one of the ways early injection can be performed, okay. This is in user mode, okay. When you develop this kind of security or protection software, the best is to run kernel code. At this time I'm only showing you user code. In the future I will show you kernel code, but sometimes there are customers that are not allowing kernel drivers to be installed, okay, because they are afraid of the BSOD, or if you do something bad in kernel code, you crash the entire system. That's basically one big reason why some customers don't like installing kernel drivers. Okay, but well, anyway, when you use kernel coding, you have full control on this. For example, if you use a mini driver, you are able to detect almost all operations that are done on all file systems: open file, read file, close file, move file, delete file, whatever. You can also detect, well, this is not mini filters, but in kernel coding you can also detect when a process gets loaded, when a library gets loaded inside the process, when a thread is created, when a registry is accessed. There are many operations that you have full control, and sometimes you can abort doing things, okay. So it's very powerful, but at the same time it's a little risky if you don't know what you are doing. So let me check if I forget something, but well, I think it's enough. The tricky thing of this video is this little function. Again, you must intercept the create process. For example, I load this library inside Explorer, okay. When you type cmd, create process is called with the cmd in the command line. What I do is to create this process in suspended mode. I inject this same DLL inside cmd.exe, so it gets injected in a very soon stage, okay, and then I resume it. Okay, when I resume it, the DLL is already injected. So at this time I already hook all the LoadLibrary APIs inside cmd.exe. When in cmd you run, okay, the little program that I have coded, okay, create process is executed, okay. I launch the little program, okay, again I suspend it, okay, I inject my DLL, that is the malware DLL. Sorry, I inject the DLL. Sorry, I inject this DLL. Okay, I inject this same DLL that does all the hooking inside this little sample program, and then when I inject this DLL hooks the create process plus the load library. When I resume the thread, okay, when this little demo program in the main function calls load library, in this case the load library API gets intercepted. I detect that the malware library is tried to be loaded, and I avoid loading this library. So it's a kind of chain, okay, where the create process injects the DLL in the child processes and all this stuff. This is not really working fine for the whole system. It's just a demo, okay, but in practice you should use, first of all, to inject it initially in all processes that are running. You should use for example a Windows driver. By this way you have full control. When the user kills Explorer, for example, the Windows driver will detect that another instance of another Explorer instance has been created, and it injects it again. Why shouldn't you use a shell extension, for example? Okay, because in a shell extension the library is not always loaded. For example, if you don't do a right click on a folder or on a file, depending on the shell extension type, your library will not get loaded. Your library gets loaded when suppose that it is a context menu extension, when a context menu must be shown for first time. Okay, so if the user never does a right click, then your library would never be loaded. That's why injecting your library, if you want to inject the library in Explorer, for example, in this case, that's why a resident program or a service must be used. Okay, but even so, I mean, there are cases where create process W is not used, okay, and another API is used to create the process. Well, there are many cases that should be covered that it's out of the scope of this video. This is a very simple project, but it will not really work for a commercial software. Okay, it's just a way that allows you to understand how important is early injection and one of the possible ways of doing it. Thanks for watching and see you in next videos.